Alrighty students, this video is going to review some things that we've talked about for the past month about growth and add some new information. So first of all, we know that growth is the number of tiles that you add to get to the next figure number. So as we look at this tile pattern, you should see that you add one on the end of each part sticking out, so that growth is 4. In this table, we look at how growth increases on the y value from one to the next, and so this growth is 3. In the equation, we discovered that growth was the value that was the coefficient of the x, the number that gets multiplied times the x. Then we looked at growth on a graph. We saw that growth was the number of blocks that you went up or down, in this case down, to get over to the next point on the line. Finally, we were looking at growth in the cost of pizza. We discovered that the growth was the cost per topping, which is actually a unit rate. Interesting. And boys and girls, I have a new word that we are going to use in place of the word growth. It is slope. So, grab your worksheet. It's blue. It has holes in it. It's valuable. Here it is. Let's fill in some information. First of all, we've used the word slope here and there in class, and I think you recognize it when we talk about a hill, and that means the steepness. Let me make that a little bit thinner. It's not getting thinner. The steepness of a line. Alrighty. So one way we are going to recognize slope is how much do you rise over how much do you run. That kind of relates to the graph. How many blocks do you go up to how many do you go over? Another way, if you think about on the table, is the change in y over the change in x. On our table, our x had always, well, most of the time been changing by 1, so we didn't really look at it too closely. But we're going to see that sometimes it doesn't. Let's move this down here and focus on how do we find slope from a table. So we need to find the constant change. The constant change of the x and y values. That's what makes it a straight line, right? When it's changing by the same amount or a constant. And we're going to write the slope as how y changes, the change in y, over the change in x. So let's take a look at this table. On this first table, as we go from this y value to the next, from 3 to 2, y changes by -1. And in the x, as we go from 0 to 1, it increases by 1. So my change in y is -1 over 1, and I think even before this lesson you would have said that the growth was -1, and now we're going to call that the slope. So now in this next table, I've made it a little bit different than we usually looked at it. On the y value here, we see goes from 0 to 2, or a change, it increases by 2. Now, on the x side, though, from -2 to 0, we're also increasing by 2. From negative 2 to 0, we have to add 2. So our change in y of 2 over our change in x of 2 is actually equal to a growth of a positive 1. Kind of fooled us on the table, didn't it? Okay, let's now let's look at finding the slope from an equation. Here's an equation, and I think we know that the slope has been the coefficient of the x. Now we have a new name for it in this equation, y equals mx plus b. Slope is going to be referred to by the letter m. You can think of m as standing for mountain, and mountains have slopes, so that may help you remember it. So it's important that the equation is solved for y. If you had an equation that looked like y plus 2 equals 3x, you may or may not recognize that the slope is 3 because the 2 is over here. So you could subtract 2 from both sides, and then you would know y equals 3x minus 2. So slope, we mentioned with the pizza, is the rate of change, or the unit rate. Therefore, it has to be next to the variable x. And the slope is the coefficient. You've heard and seen that word many times. The coefficient of the x. That's why we want to write it in front of the x. Okay, now we need to talk about finding slope from a graph. We've done this a little bit. We've talked about how you want to choose any 2 points on the line. We want them to be lattice points, L-A-T-T-I-C-E. Those are the ones where the 2 lines intersect on the grid, so you can read the points and the values more accurately. So you want to count the rise, that's the up, sometimes the down, and then the run, how much it goes up and how much it goes over. And then you write the slope as the rise over the run. Slope is rise over run, something we'll remember. And so on your graph you have a line that looks similar to this, and if we want to find the slope, you can see there's a point right there on the y-axis. That's a special point. We call that the head start. We're going to have a new name for it coming up here soon. And you should be able to see on your graph that there's another point there, there's another point there. And again, we can choose any 2 points. So let's look at a couple. Suppose we go from this point on the y-axis up and over. You had to rise 2 and run 1. Well, so our slope is 2 over 1, or 2. It grew 2 to get to the next figure number. Rise 2, run 1. Suppose you say, what about if I go from this point to this point? Well, you need to, in this case, rise. Let's count. 1, 2, 3, 4, 5, 6 to go over 1, 2, 3. So if you rise 6 and go over 3, isn't that still a growth of 2? It is. So that's important to realize, that it doesn't matter which 2 points you pick on the line. Pick good lattice points, but your slope will always reduce and be the same. It's the same straight line, right? So the slope can't change no matter which points you pick. Okay, so now let's look at finding the slope from 2 points. This really isn't any different from what we looked at in the first box about finding the slope on the table. So they said to label the x and y coordinates on here. I want you to think about this being on a table. So you kind of got to have your points stacked. And then their next directions up here is that you're looking for the change of y and the change of x. So in our y values from 3 to 9, we add 6. In our x values from 2 to 5, we add 3. So the important thing is that we write the slope as the change in y over the change in x, or the rise over the run. That's the change in y over the change in x. And so this was 6 as our change in y over 3, our change in x, so that has a slope of 2. Let's look at another one. Suppose you have points 0, 3, and 2, 2. Take a minute and you try finding the slope between those 2 points. Okay, did you pause the video? Find the slope so you can think about them as being on a table. How does y change? From 3 to 2, it decreases by 1, and from 0 to 2, it increases by 2. So if you're going to write your slope as the change in y, or the rise, we have a negative 1 over the change in x, or the run, of 2. Can that be our slope, negative 1/2? Yes, it can.